Hello everyone, this is Dr. Young, and in this last lipid video, we're going to talk about steroids and kind of see how structurally they're different than a lot of the other lipids that we talked about, and how do we identify them, and what are some of the functions of steroids. So remember, right, lipids are a big class. They just mean that there are a bunch of biomolecules, right, that are not very soluble in water. We already talked about triglycerides. We already talked about triglycerides and phospholipids, and so in this video, we're going to talk about the steroids. So steroids like this steroid up here, which is esterone. And which is one of the estrogens, and we just want to make sure that if I look at this steroid, if I look at esterone here, that it does in fact look like it is a steroid, right? Or sorry, that it is a lipid, that it's not very water soluble. And so I'd see that it only has two polar functional groups, right? And if I take a look at how many nonpolar carbons, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 nonpolar carbons compared to only 2 polar functional groups. Not enough to make it water soluble, not enough to make it overall polar, right? So we'd say that estrone, all of these steroids that we're about to see are pretty non-polar. They're not very water soluble, so we'll talk a little bit about how they need help moving around in the body. And again, before I move on here, I just want to reiterate, right? I'm not going to hold you responsible for terpenes or prostaglandins or waxes in my class, or the other lipids. I just want you guys to focus mostly on the triglycerides, the phospholipids, and the steroids. So if we're looking at steroids, right, they are defined by what's called the ABCD, or fused ring system. And if you look at all of these steroids, right, this is from a paper listed down below there, they all have something in common, right? If you look at them, they all have the same sort of carbon skeleton in the middle, right? If I look at this cholesterol up here, right, this is what's called the ABCD ring system. And if I can look at any of these, and I can see an ABCD ring system, an ABCD ring system, they all have the same structural feature. And then the other things dangling off of that are what differentiates, for example, an estradiol and testosterone, etc. So the ABCD ring system is a 6-membered ring, fused to another 6-membered ring, fused to another 6-member ring, fused to a 5-membered ring. That's what we mean by the ABCD ring system. And then everything else, like I said, is just different groups coming off of that basic skeleton, that basic motif. That's what we're looking at here. So there's lots of different steroids. I'm not going to expect you to go draw cortisol or go draw testosterone or anything like that, but I do want you to be able to identify a steroid. And you also notice that steroids don't have subunits, so they don't have that steroid, they don't have that subunit macromolecule relationship. Steroids just are steroids. They aren't made up of individual smaller pieces, but they are very easily recognizable because of this ABCD ring system. So let's take a look at some of the functions of steroids. Usually when I ask my students, right, what do you think of when you think of steroids? Everyone talks about bodybuilders getting jacked and trying to build muscle and stuff like that. That would be an example. That is anabolic steroids, right? Those are anabolic steroids, things that help you build up muscle tissue. But that's not all steroids do, right? I often have students remind the class that they're also used for inflammation. Right, so you could take some sort of anti-inflammatory steroid like a cortisone, or you might get one in an inhaler if you have asthma or something like that. That they do other things. It's not just to get all jacked and swole or something like that. So for example, I have here progesterone and testosterone, which are two of the sex hormones. So I'll put sex hormones. Right, and it's not just as a reminder, you've probably heard this in other classes, right? It's not like only men have testosterone, it's just we have higher amounts of testosterone, and it's not that women only have the estrogens, estradiol, estrone. They just have higher levels, right? Basically, everybody has all of the different sex hormones. It's just the balance of which, all men have the estrogens, for example. They're just relatively low amounts. But the jobs of these, like progesterone and testosterone and estradiol and stuff like that, right? Their function here, so I'll put function. Their function is to act as chemical messengers. So I'll put chemical messengers. Right, or another word, right? Another name for chemical messengers are hormones, right? They're hormones. And we talked about with proteins, right? Proteins also can be hormones, right? We talked about insulin is a hormone, oxytocin is a hormone. A hormone is just a chemical messenger. It's just right where a molecule's job is to tell the body to do something. So like progesterone and testosterone, right? They tell the body how to develop. They don't They're not the thing that does the developing. That would be a protein that is like making the muscle tissue or something like that. They're just telling the body to start doing something. So they're just trying to talk. They're just trying to talk to your body, send messages around the body. Then we have molecules like bile salts, which look kind of different. They should look kind of different to you, right? If I look at progesterone and testosterone, they definitely look like they're not very water soluble, again, because they only have 2 polar functional groups and like 15-ish nonpolar carbons. But bile salts, it's not really the case. Bile salts have a lot more polar functional groups, and in fact, even an ionic bond in there. So they tend to be a lot more water soluble. They're the most water soluble of these steroids. So bile salts, they're fairly water soluble. So I'll put fairly water soluble. And that has to do with their function, right? You may have heard of bile salts before, or bile functions. Right? The function of a bile salt is to be excreted when you start to eat fats. And the idea here is that when you eat fats, right, the problem is that fats, as we know, do not mix with water. And your insides are largely water, right? And all your digestive fluids are water. They're aqueous solutions. And so the fats don't want to mix with your aqueous digestive fluids. And so you need to find some way to get them to mix in, right? It'd be really weird if you just had like a layer of fat floating on top of your entire digestive tract. That would be hard for you to digest. And so what bile salts do is they act as emulsifiers, or like they act as a soap, basically. So I'll put act as an emulsifier to aid with fat digestion. Which means they basically they're acting like a detergent, like a soap, right? To try to get that thing that's really hydrophobic, like a triglyceride, which we talked about, right? If you eat some butter or something like that, to try to get that to help kind of mix in with your digestive fluids so that it can actually move into your small intestines and move through your digestive tract and encounter lipases and get transported across the intestinal wall and all that sort of stuff. So bile salts, their main function right here is to act as an emulsifier to help you digest those lipids that might be in your diet. People who have their gallbladder removed sometimes have trouble with digesting fats, because with the gallbladder removed, that's the organ that kind of stores the bile salts. The liver makes the bile salts from cholesterol. All right, so your liver takes cholesterol, turns into bile salts, it gets stored in the gallbladder, then the gallbladder is attached to the small intestine, and it excretes the bile salts as you eat fatty things. So again, its job is to just act as an emulsifier for when you eat fats. And then lastly, we have kind of the most misunderstood steroid, which is cholesterol. People usually talk about how cholesterol is bad or good. Right, so you have bad cholesterol or good cholesterol, and that's really kind of a misnomer. They don't really mean good or bad cholesterol. What they mean is good or bad cholesterol rafts or envelopes that carry cholesterol around. This molecule here is cholesterol, and it's not like there's like a bad cholesterol and there's like a good cholesterol or something like that, right? Cholesterol is cholesterol. This molecule right here with these carbons and hydrogens and oxygen, that is cholesterol. There is no good version or bad version. The bad thing, when the people say bad cholesterol, they're talking about a lipoprotein, a low-density lipoprotein, or they're talking about the good cholesterol, which is the high-density lipoprotein. So those are lipoproteins. Those are carriers. They carry cholesterol around the body. So I'll put they carry cholesterol around the body. And you need these protein rafts. You need something to carry cholesterol around the body because, right, cholesterol is not very water soluble, so it's not going to be soluble in your blood plasma or anything and just be transferred around like that, like a salt or a glucose or something like that. They need something to carry them around. So that's why they have these lipoproteins. That's what the L stands for at the end, the lipoproteins. So these carry cholesterol around the body. And depending on whether or not cholesterol is going from your cells to your liver or delivered to your cells, those are considered markers for better or worse cardiovascular health. We are not going to get into that. That's a kind of a different class. But I want you to know that there's no such thing as good or bad cholesterol molecules. Cholesterol is cholesterol is cholesterol. It's just one molecule. That's it. It's this molecule right here. Now, cholesterol, what is the function of cholesterol? I'll show you this diagram in a minute, but the function of cholesterol here is, it's really important. It's in every single cell membrane in your body. And the idea is that it helps maintain the fluidity So I'll put maintains fluidity of the cell membrane. So you find cholesterol embedded in your cell membranes, and it helps them from getting either like too liquidy or too solid. It helps them have just the right fluidity so that proteins and stuff can float around in them. So let me show you what I'm talking about. Right, I've shown you this. This is your phospholipid bilayer before, right? We have all the phospholipids drawn here with their red heads and then the yellowish tails. You got your bilayer. We've got all these blue things. These are proteins shooting through. We've got a bunch of sugars on the top face, right? This would be the exterior over here. This would be the exterior. This is the interior of a cell. And again, you'll notice here, right? You'll notice that I have cholesterol. That's what these things are. I think I even mentioned it in the previous video, but I got a cholesterol molecule here, that little thing in yellow. I've got a cholesterol molecule here. I've got a cholesterol molecule here. And realistically, there's probably even more cholesterol than this is representing. There's a lot of cholesterol in your cell membranes. And again, the idea is that it kind of helps stop these hydrophobic tails, these fatty acid tails, from stacking too well so they don't like solidify, right? It'd be kind of like putting a stick of butter in the freezer. You know, it gets so hard you can like not really put a knife through it. You don't want that to happen to your cell. You don't want it to get so hard that these proteins can't float around in them. Conversely, you don't want to like make it so liquidy that it gets too fluid. And so cholesterol kind of helps maintain that, maintains that difference. And so your cells can either insert more or less cholesterol to kind of help maintain that fluidity. So they're super important. Cholesterol is a very, very, very important biomolecule. Without cholesterol, your cells would not function correctly. It's a really big deal. So cholesterol is not like a bad thing. You're going to make cholesterol. You make cholesterol all the time. It's really important. Also, I want to point out here that if you take a look at this, right, here's that big picture of all those different types of steroids. If you look at this, right, this is the biosynthesis of these steroids. This is how they're all connected to each other, right? Like the idea is that you would take cholesterol and you turn it into this and then that, and this gets turned into these things, and it gets turned to cortisol, or maybe it gets turned into here and it gets turned to testosterone and then this, or maybe it gets turned into estradiol and then esterone, right? This is just telling you what this pathway looks like. What I really want to point out here is that you'll notice that the whole pathway starts with cholesterol, either just straight up cholesterol or the cholesterol sulfate. So when you're talking about like making these hormones like estrogen, like the estrogens, estradiol and testosterone or esterone, or cortisol for that matter, they come from cholesterol. You turn cholesterol into all of these really, really important steroids. And sometimes people who are having hormonal issues, if their steroid levels are off, sometimes people actually recommend that you eat more cholesterol so that you have more of this starting material so that you can build more of the type of steroid that you're looking for. So my point is just, cholesterol is a really, really important biomolecule. Don't naysay it. It's super misunderstood. The discussion about the high-density and low-density lipoproteins, HDL and LDL, that's a separate issue. We're not going to talk about that. So hopefully you feel like you have a better idea of what steroids are and what they aren't. They don't have subunits and macromolecules. They just have that ABCD ring. Main functions, right, is that they act as hormones, they aid in digestion, and they're important structural features in your phospholipid bilayer. So if you have any questions or comments, please leave them down below. Practice, practice, practice. Happy studying.